Okay, this is similar to the other video. This is going over part B. This is going to be more normal stuff and more problems from chapter 2 in your textbook. So, following table shows the number of miles a hiker walked on a trail each day for 6 days. What was the mean number of miles the hiker walked for the 6 days? Well, we can figure that out a couple different ways, but I'll show you technology-wise what you can do. So let me make this a little bit smaller. Okay, so what you can do on this problem, remember mean is the total, all the numbers added up divided by how many there were. So for the first day, there's 8 miles, 5 miles, 7 miles, 2, 9, 8. Well, let's just add them together and divide by 6. No, you could put them in your stat menu, but honestly, this is 357,298, or 857,298, and then there's 6 days, so divided by 6. So 6.5, 6.5. That's just straight up calculation there. All right, number 2. How do I get to the next problem? Okay, there it is. All right, the second one, the following list shows number of goals scored by a soccer team in 9 games. How does the median number of goals scored compare with the mean number of goals scored? 0, 0, 1, 1, 1, 3, 3, 4, 5. Just kind of looking at it, the median 2, 4, 5 would be 1. The median is 1. I would say the mean is going to be a little bit less because there's 3 1s as opposed to only 2 3s and 4 and 5. Let's just double check it though. I mean, the mean can be calculated pretty quickly without doing a whole lot. So 0, 0, 0 plus 0 plus 1 plus 1 plus 1 plus 3 plus 3 plus 4 plus 5. Is that 9, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9. So, I was wrong. Actually, the mean is higher. It's going to be 2. So the mean is 2. The median is 1. The median is less than the mean by 1 because the median is 1. And it's not letting me pick that for some reason, but all right, so we got 6.5 there. Then the median is less than the mean by 1. The median is, okay, well, it is this one. Okay, number 3, the data for a stats project. A student asked 10 friends how many hours of sleep they got on the previous night. The data are shown in the following list. What's the IQR of the number of hours of sleep shown in the list? These are all out of order, so let's do a refresh on how to do this in your stat menu so you can get your quartiles. So we have 7, 6, 5. We're going to go ahead and go to stat, edit, and in L1 you do 7, 6, 5, 9, 3, 4, 7, 9, 5, 8. So there should be 10 numbers in there. And then you're going to go to stat, calc, one variable stats, calculate, and your quartiles are 5 and 8. 5 and 8. Q1 is 5, Q3 is 8. IQR is the difference, so 8 minus 5 is 3. 3. The time in minutes All right, now we got it working again. The time in minutes it took for each of 11 students to complete a puzzle was recorded and shown in the following list. You can read those numbers. One of the students who completed the puzzle claimed that there were 2 outliers in the data set based on the 1.5 IQR rule for outliers. Is there evidence to support the student's claim? Well, let's get those quartiles so we can tell. So you don't have to guess on this. You just enter the data in. You can go to the top of the list and clear it out if you have old data. Now, I'm likely to believe the 58's an outlier, but we're going to double check it. So you should have all the data in here. Now you're going to go to Stat, Calc, One Variable Stats. And my quartiles are 32 and 20. 32 and 20. So the IQR would be 32 minus 20, which is 12. So 1.5 times 12 is 18. So remember, the 1.5 IQR rule means if you add that number to quartile 3, so quartile 3 is 32, anything above 50 is considered an outlier. And if I look at my quartile 1, 20 minus 18, anything below 2 would be considered an outlier. So I only have one outlier, and that would be the 58. So it's going to be this one. Question 5. A reporter collected data on the purchase prices in thousands of dollars in cars sold in a region. The following histogram summarizes the reporter's data. Looks somewhat symmetric, but then you got an outlier over here. Let's see what's going on with that. For a presentation on the data collected, the reporter used the median of the distribution to describe the typical purchase prices. Which of the following might explain the use of median to describe the typical purchase price? There is an outlier between 80,000 and 85,000. Medians are resistant to outliers while means are not. So that's a good thing because using a median kind of eliminates the bias that this number creates. So I'm gonna probably go with that one, but let's look at the other explanations. The number of observations that fall within a given interval is known. However, within each interval, the actual values are not known. Well, we can kind of estimate those, so that's not true. The distribution is skewed left. More skewed right because of that outlier. The values represented in the histogram are in the thousands. Yeah, but it doesn't explain why we chose the median. The distribution is uniform. Definitely not uniform. But we choose a median as opposed to a mean because if there's any outliers in either direction, it's going to make the mean higher or lower toward that outlier. So it's going to be this one. All right, next question. The distribution of 27 salaries at a small company has a mean 35,000 and a standard deviation of 2,000. Suppose the company hires a 28th employee at a salary of 120,000. Which of the following claims about the new salary distribution is supported? The median is not likely to change. The range is not likely to change. The mean is likely to increase. So if you have this really high employee with a relatively small standard deviation, remember that even if this is not skewed, even if it's normal, if you got 35,000 as your mean, if it were normal, if we're only going 3 standard deviations out, that's 37, 39, 41. You got this person here, that's going to pull the mean in that direction. So that mean is going to increase, but the range, well, that'll increase for sure because the range is going to include the highest minus lowest. So those are both true. The range, oh, sorry, the range is not likely to increase. So that's not true at all. Yeah, the range will increase. The median is not likely to change. Yeah, one number is not going to change the median a whole lot, but I would say 3 is going to be your deal there, okay? All right, the following box plot summarizes the heights of a group of people who participated in a weekend biking club. So take a look at that. Remember, this is 25% of the data, another 25%, 25%, and 25%. And each part of the box plot is a quartile. So this is 25%, 50, 75, and 100. Which of the following statements is supported by the box plot? The mean height is 67 inches. We can't get mean from a box plot. No. The number of people with height at least 70 inches is greater than the number of people with height at most 62 inches. So at least 70 inches, we don't know how many people there, but between 70 or at least 70 inches, that's a quarter of the people. At most 62, that's another quarter of the people. Those are gonna be the same amount of people here as there are there, okay? That short whisker doesn't mean there are less people. It just means it's more concentrated between those two numbers. So that's not true. The number of people with height at least 67 inches is less than the number of people with height at most 67 inches. So at least 67 inches is the median. That means half of them are going to be here and half are going to be there. That's equal. Approximately 50% of the people have a height between 62 and 70 inches. 62 and 70, that middle 50%. Quartile 1 to median, that's 25%. Here's another 25%. That's half the people. So approximately 25% of the people have a height greater than 62 inches. So that's not true because this is 25%, that's 25%, that's 25%. So all three of those combined is 75%. Greater than 62 is going to be 75%, not 25. All right, so it's going to be E. Next question, number 8. The following table shows statistics on the ages and years of the people who attended a lecture last week. It's got your number, standard deviation, mean, and all the quartiles and 5-number summaries. Which of the following is supported by the table in the box plot? The range of the distribution is 20 years. Well, the maximum and the minimum, 65 minus 20 is 45. I mean, that's just not true. So that's not true. There were 40 people, 3 people who attended the lecture. There are 45 people. N is the number, so it's not that. At least 50% of the people who attended the lecture were 43 years or younger. The median is 44, not 43, so it's close, but, well, hold on. No, because it says at least 50%, so that's not true. D, at least 75% of the people who attended the lecture were age 53 years or younger. All right, quartile 3 is 53, 75%, 53 years or younger. That would be true, 25, 50, 75. So it's gonna be this one. At least 25% of the people who attended the lecture were 33 years old. We don't know the individual numbers who were 33. That's quartile 1, but there might not be anybody at 33 years old. That could be the average of 31 and 32 and 34. So we don't know that, but we know this. Number 9, the following box plot summarizes the earnings made on one day at 45 movie theaters. I missed movie theaters. Which of the following best compares the median movie theater earnings for the mean movie? So you got a box plot here, then you got these huge outliers, 3,000, a little bit under 5,000, a little bit over 5,000. You know that mean's going to be higher, okay? So the mean and median are not equal. The median is less than the mean, but the distribution is not symmetric. The median is less than the mean because the distribution is skewed to the right. Remember, on the x-axis, is it's right is this way. So the 5,000 would be here. Yes, it's going to be skewed to the right. Median is less than the mean because it would be skewed to the right. Median is less than the mean. Mean is more. All right, number 10. Okay, researchers studying catfish estimated the number of fingerling catfish and large catfish living in different rivers throughout the country. The following histogram summarizes the relative frequency for each type of catfish. Okay, this one's kind of all over the place. Relative frequency, remember, is a decimal. This one's kind of steadily going downward. So this is number per river. Oh, these are the fingerling and the large. So keep that in mind. Based on the histograms, which of the following is the best comparison of the means and the ranges of the two distributions? The mean and range of the fingerling catfish are both equal to those of large catfish. I don't know the mean, but if you look at these numbers, you're like between 6,000 and 8,000 probably, maybe closer to 7,000. Where's the mean here? That's going to be more like, I don't know. The mean are not and range are not the same. The mean and range, so the mean and range of the fingerling catfish are both less than. I would say the mean's higher than of the fingerling is higher than the large catfish. Also, the range, you're going from like 3,000 to 11,000. That's an 8,000 range, where this is only like 2,000. So I would say that both the mean and the range are going to be higher for the fingerling than the large. So it's going to be this one. All right, number 11. We got data. A sociologist studying marriage customs collected data on the length of time in months between the proposal and wedding. The following box plot and table give the 5-number summary for couples in which at least one person was getting married for the first time and for couples in which both people had been previously married. So we have first time, previously married, minimum, quartile 1, median, quartile 3, maximum. So it doesn't have any means. But let's take a look. Based on the summary statistics, which of the following is supported by the box plots and table? The mean length of time for the first time couples is 18 months. We don't have means. We don't know that number. All right, B, there is a gap between 20 and 36 for the first time married distribution. We don't have that number. We don't know. There wouldn't be, because there's going to be some value here, right? 20 and 36. Because both distributions have a minimum of 0.5 months, the distributions are skewed to the left. Well, that's not true. This one is not. This one is not skewed to the left. This one is maybe slightly skewed to the left. The number of first-time couples in the study is greater than the number of previously married couples in the study. And we don't have that information, so we can't answer that. The interquartile range of length of time for first-time couples is greater than the previously married couples. So this box is wider than this box. That is true. So it's E. Question 12. Based on the 1.5 IQR rule for outliers, which of the following statements is a correct comparison of the two distribution? Okay, let's do some number crunching, I guess. So 1.5 IQR rule. Okay, hopefully you can see my calculator. So let's take a look at the top one. IQR would be 320 minus 278. 1.5 times 42. So if I do 278 minus 63 and 320 plus 63, anything lower than 215 and higher than 383 would be an outlier. And we don't have that here because we have 239 as our minimum and 330 as our max. So electrical does not have outliers. Concrete, we would do 308 minus 262, times that by 1.5. That's 69. We do 262 minus 69. Anything below 193 is an outlier. We do 308 plus 69. Anything above 377 is an outlier. So we don't have anything above 377, but we do have 186. So concrete has one outlier. It is on the low end. The concrete distribution has at least one lower outlier, and the electro distribution has no lower outliers. That would be the true one because it doesn't have a high outlier, it only has a low outlier. All right, number 13. In the Dominican Republic in August, the distribution of daily high temperatures is approximately normal with a mean 86 degrees. Approximately 95% of all daily high temperatures are between 83 and 89 degrees. What's the standard deviation? Well, let's draw this out. Remember, the empirical rule is 68, 90, 95, 99.7. This is plus or minus 2 standard deviations. So if you have your mean, which we got 86 here, and we go to 83, and we go to 89. Now I want you to understand this. This is not, 83 is not one standard deviation. This is actually 2 out because it's talking about 95% of the data. So there's going to be a middle number here, right? So what's halfway between 83 and 86 is going to be 84.5, and 87.5 will be halfway between 86 and 89. So this is within 2 standard deviations. That's 95% according to the empirical rule. And so that means your standard deviation, 1.5. All right, next question. Which of the following can reasonably be modeled by a normal distribution? Favorite colors of students in a kindergarten class. Those are not quantities, so that's not going to work. Heights of tomato plants that were planted on the same day. Possibly. Let's look at the other ones. Percent of employees from a company who attended a company retreat. That's just a straight number. So that's just a value. That's not a whole distribution. The average number of siblings of all students at a particular high school. I'm likely going to say no on that because it's likely not going to be more than, like the mean might be maybe 1 or 2, 2 or 3, but that standard deviation, you know, most of them are going to be between 0 and 3 probably. So that's not really something you can do a normal distribution. Parental guidance ratings of movies filmed in 2019. These are not quantities, so that's not going to work. But the only one that really works is heights, right? Because you planted tomato plants, you're going to get a lot of variability in those plants. So I would say it's going to be that. Most of them will be in the middle. All right, look at the next one. 15. Family has 2 cats named Gordo and Flaco. Gordo weighs 15 pounds, Flaco weighs 8 pounds. The cat's weight is classified as unhealthy if the weight is located in the top 5%. Bottom 5% of all cat weights. Distribution of cat weights is approximately normal with a mean of 9.5 and a standard deviation of 1.5. So we're talking like 1.5, that's going to be 11, 12.5, 8, 6.5. We can go further on if we want to. Which of the following best describes Gordo and Flaco's weight? Gordo weighs 15 pounds. Well, 15, Gordo's going to be over here. And that's going to be, if you look at, let's see, 11, 12 and a half, that's going to be 14. 15 is going to be in the top. Remember, that's the top 0.15%. So Gordo is in the top 5% of weights. Flaco is 8 pounds. Flaco is not considered in, like, if you look at the empirical rule, this is going to be 16% over here. So he's not going to be too light, but Gordo's weight's unhealthy. Flaco's is not. Flaco's. Gordo's going to be too high. He's real small, 0.15 percentile. All right, next question. 16. Distribution of number of transactions filled in a bank each day is approximately normal with a mean of 478, standard deviation of 64. Which of the following is close to the proportion of daily transactions greater than 350? Let's use calculator. So normal CDF. Second vars, normal CDF. Mean of 478, standard deviation is 64. Let's go ahead and put those in. And which number of daily transactions greater than 350, which means 350 will be the lower. The upper will be 1E99, that's positive infinity. 1 second, comma, 99. So that should be approximately 0.977, pretty high number. So that's going to be this one right there. 0.977. Number 17. Distribution of customers purchased at a convenience store is approximately normal. Mean of 15.5, standard deviation of 1.2. Which of the following is closest to proportion of customers between $14 and $16? Again, normal CDF. See how much quicker that is in the table, right? You're going to do 14, 16, lower, higher. Your mean is going to be 15.5. And your standard deviation is 1.72. Let's plug those in, see what we get. .422, so it'll be C. Again, that's going to be this right here. Just plug them in like that, normal CDF. And last one. This one we'll have to solve a little bit. So we'll do a little writing. The distribution number of moths captured per night by a certain moth trap is approximately normal with a mean of 103. If 28% of the captures fall below 76, so we don't know this we know this percent is 28%. We know this is 76 right here. What should the following equations be used to find the standard deviation of the distribution? So what we want to do on this problem, this is talking to you about how to interpret this, is you want to get the z-score. So you do 76 minus 103. We don't know the z-score, so, or we don't know the standard deviation. We do that. But we have to know this number right here is z, all right? And we can get the z from either the table or do a normal inverse norm. So what I do is I do inverse norm. And let me go through that process here. Do the inverse norm. Second vars go down to 3. Your area is going to be 0.28. you leave your mean and standard deviation at 0 and 1 because you want to find a z-score. Okay, your z-score is when the mean is 0, standard deviation is 1. So that z-score is a negative because it's less than 0, less than that, that mean. So negative 0.58 is your z. So z is negative 0.58 when the probability that z is less than negative 0.58 is equal to that 28%. Okay, so there's your z. And solving that equation will get you your standard deviation. So it's going to be D. All right, just in time to start class. So hopefully this was helpful for you. Okay, you have a great day.